goes on. Right now, the two cases of law of sines that you guys have been working with that you probably didn't even realize is what you were doing was that you guys had angle, side. You were given two angles and a side, or you were given angle, side, and angle. Don't freak out that you're doing any proving of triangles or anything here. I'm just showing you what your givens were in relation to the problems. Okay? Most of the things you had were those. Well, those are the real nice and easy ones with law of sines. Those are always going to work out cleanly for you. What happens here is that you get what's called an ambiguous case. And the ambiguous case is kind of the iffy. It may or may not work. It might work for a triangle. It might work for two triangles. It might not work at all. But it does sometimes. It's like a great thing of ish. It's law of sine ish, if you will. And that is the got to cover your SSA in this one. All right. So what happens here is that you've got to be careful with what's called the ambiguous case of side-side angle. And before I get into too much of what all this means, I'm going to kind of show you guys a little bit of what we haven't done yet in regards to sines and cosines. I think that by showing you guys this method as opposed to what they show in your book is a lot cleaner. It's a lot less that you have to memorize as far as formulas and stuff are concerned and how to check things. Because the way that your book has this written out is that there's about 6 or 7 different scenarios that you have to check for to see if something may or may not work. By doing it this way, it's really easy. And it comes from this. Let me ask you this. What's that? A graph, okay. A weird T. A quadrants. Thank you. Now, in your quadrants, you have x's and y's, right?
Yes.
Okay. They're both positive here. Okay. Now, could I also do this and say that this is at 0 degrees, 90 degrees, 180 degrees, and 270? You're right. 360 comes up when you come all the way around. It becomes 360 when you come full circle. That was punny. All right. Are we okay with that?
Yeah.
Okay. Now what I want you to do is tell me what is the sine value of 60 degrees. What's the sine value of 60? You should know this off the top of your head. What's the sine of 60? You have a calculator if you can do it in your head. Don't hurt me. You're in radians.
Oh, wait, no. No, I'm in degrees.
Oh, okay. So the sine of 60 is, let's make it easier on your brains here. Do sine of 30. Sorry, we'll do it this way. We'll do the sine of 30.
0.5.
Okay. So the sine of 30 is at a half. What's the sine of 150?
What? What in the world?
Here's what's happening. What's happening here is what we call a reference angle, but we're going to talk more about this after we get done with law of sines and law of cosines. What happens is when you are bouncing off the x-axis the same amount of degree value, coming up on this side, coming up 30 degrees, and coming up 30 degrees this way, these two values wind up in the same horizontal position. Their endpoints would be at the same horizontal position. Do you agree on that? Don't even think that. Stop. Now, if they're the same horizontal position, think in terms of x's and y's, which value is the same for both of them? The y value. So that's why the y value for both of these is 1/2. Because the sine of an angle can be positive in both the first and the second quadrant. They have the same what's called reference angle. Okay. Now, if this is 30 degrees coming up here, you guys just told me coming around this way, it's 150. Notice how 150 and 30 are supplements to one another? That's because that 30 degree is how far is it off of the x-axis? How far does it bounce up? Does that make sense? So no matter where I place an angle in here, if it's up here at 60, and up here, up 60 here, this one would be up 60, this would be up 60. These two would share the same y value. And you guys just told me this a second ago was like 0.86. In other words, it's root 3 over 2. It's the same y value going across one another because they're on the same horizontal plane. Okay. That tells you that an angle can have the same sine value between 0 and 180. There's always two angles that have the same value for sine. Does that make sense? Something. Okay. When we get into this further along, you'll also start to realize that you're going to get cosine values that share the same value when they're in the second and thirds, and so on. There's little nuances that occur here and there, all right? And it all goes from horizontal and vertical slopes, sharing the same x or y coordinate, right? So what this is going to allow us to be able to do is work with what we call these ambiguous cases. And I want to show you this just right off the bat of how this, what happens. Let's say we have this. We have angle A is 70 degrees, side A is 155, and side C is 160. Let's say we have that scenario to start with. Just like we have in the past, what do you think my first thing to do is? Draw. So we just draw a real simple diagram. Angle A is 70, side A is 155, and side C is 160. Notice how the sides and the angle match out with the idea of angle side side, otherwise known as side side angle. This is the case that you have to stop and just slow yourself through. Because from now on, when you see this, and I don't know if you noticed this, I gave one like this last night, but it worked. It only worked with one triangle. This could happen where it could be one triangle, two triangles, or no triangles. And it is very, very easy to distinguish between the two, or three, I should say. All right. So if I'm looking at this, what is this problem forcing me to find first? Angle C. We okay on that?
Yes.
Set up law sines and let's try it. And I'm pretty sure you guys can do that rather easily. Sine 70 is to 155. Sine of C is to 160. Now, just like your homework from last night, the last law of sines problem you had matched up just like this. You had to multiply by the denominator and take the inverse sine. Remember that? So I'm just going to rewrite that quickly by doing this. And I go to my calculator. When I go to my calculator, I type in 160 sine 70.
Yeah.
Thanks. Enter, divided by,
155.
thank you, and hit enter. So right now, the sine of some angle equals that crummy decimal. What do?
Inverse.
Inverse sine of your answer. Use the answer key here, guys. Don't round stuff off. 75.93. Okay? Always want to go two decimals. All right? So we're okay with that. Here's what you guys did yesterday. So now you've got an angle at 75.93. Which means, I'll bring this back in a second here. Which means, if you were looking at it in terms of where the values of sine are positive, that 75.93 is here, and it also would be here. Do you agree? What's this other angle have to be? How do you find that? Subtract from 180. So here's what I'm going to do. When I'm checking these ambiguous cases, I'm going to call my first angle just C. and the second angle, C prime. Is that okay? Just to show that's another possibility. So when you subtract that out, you take 180 minus the 75 and change. What's it, 104? So the other one's 104.07. So those are my two possible angles for C. I'm going to go back to just the single page here. How many degrees are in a triangle?
180.
180. So here's what we do. We check to see if, well, if I put 75, 93 in here, is there enough degrees left over to make an angle B? What does B have to be? 3407? Okay. I try it again with C prime. So I have 70 here for A and 104.07 for C. Are there enough degrees to find B? What do you get for B then? Anna's pressing buttons. I'm relying upon her skills. 593. So how many possible triangles can I make with these values? That's all you got to do.
Wait, that's it?
That's it. But now, I'm not done, which means you have two possible angles for C, because they have two sine values, which means, yeah, but wait, there's more, it slices, it dices, it's Julian Price. There's two possible angles for B, which means there's two different side lengths that you get for B. So you just have to do law sines twice now. So that's all.
It takes some time.
It just takes a little bit of time, but you guys saw how fast it is to do law sines. It's not like, a root canal. Yes, ma'am. Okay. So what you're doing here is you're checking to see, yes. I got what's called this, I found the supplement. Remember when we're talking about, these look like cool gang signs. We should start a math games. Word. Your sine values are positive in the first two quadrants. So when you have an angle here, with this, what we call a reference angle, there's a mirrored angle in the second quadrant with the exact same angle. Because they're on the same horizontal plane when they do that. That's how that works. All right?
So all you have to do is subtract C from 180 to get your,
Secondary angle.
and
Now,
then you just went through the sine laws.
yeah. And sometimes you're going to get an angle that will work, and sometimes you're going to get an angle that won't work. So if you get an angle that doesn't work, that means you only have one triangle.
What if, is there a possibility that neither of them will work?
Exactly. I'll show you. Now, this is a great question. Let me ask you this. Just for generic ideas in a right triangle, sine of an angle, oh, we use theta, is what over what? It's always going to be opposite over hypotenuse. No matter what, it's always going to be opposite over hypotenuse. In a right triangle, what's always going to be your longest length? The hypotenuse. So no matter what you do, the hypotenuse is always going to be larger than the opposite side. Therefore, will the sine value ever be greater than 1? No. That's why. Sine will never be greater than 1 because your hypotenuse is always the longest length. Okay, does that make sense?
Yeah, but what?
Now watch, let me show you this. If you do it this way, this is where you're, I think this is where you're going here.
Oh, because the sine of 90 is 1, that's weird. I didn't get
Are you serious?
Yeah.
Try this.
The law of sine.
And the reason that that works is because what you're doing is you're working with what are called the quadrantals. This is at 1, 0. This is 0, 1, negative 1, 0, 0, negative 1. Sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. Cosine of 0 is 1. Cosine of 90 is 0. Cosine of 180 is negative 1. Cosine of 270 is 0.
And
It's
tangent just doesn't matter.
Tangent is sine over cosine.
What?
We're getting,
My like huge question about all of this is like, what is sine? Like, what is it doing that gives you that decimal? You know, like.
it's a ratio. A sine is just a comparison of two numbers by a fraction. It's just a fractional amount.
But like, what does it do? Like,
Like,
is there
what's
some
like
like
some
multiplication
sign?
in there? You know how you have like log? Like, what is log?
It's an exponent.
Okay, but what's the exponent? It's
Whatever the long lines
letters.
would be.
This is math.
It's okay.
I don't
It's
know what
okay.
it means. It's just buttons that I have to learn how to use.
Yes, ma'am.
Sine of 0 is 0.
Yes, and I want to walk you through here. So what's your first step to doing this?
Draw it out.
All right, so we draw it out.
Okay.
Walk it out.
So we have 25, 6, and 20. Which angle is this forcing you to try to find first? Trying to make you define B. So sine 25 is to 6, as sine of B is to 20.
So you just get 20 times sine.
Yep, so you get 20 sine 25. Divided by what, 6?
Yes.
Equals this, 1.4. If I inverse the sign of my answer, I get an error, which means
It doesn't work.
it doesn't work, and therefore there is no triangle.
So it'll just give you an error. If that's how you know it's wrong.
Yeah. Or if you recognize that you're going to get a sign value that's greater than 1, because you can't get sign between that's greater than 1.
Oh wait, so the sign was just greater than 1 because it was sine 25 over 6.
Correct. And you can't have a sign of an angle being greater than 1.
Okay, that makes sense.
Okay? So this means there's just no triangle. What's happening here is that one of these sections isn't long enough to connect to the other side with those angles. That's what that means. Yeah, it's a broken-hearted triangle.
That's so sad.
Okay.
When are we going to give a test back?
When the last person takes it.
I thought you were saying next week.
No, I was wrong.
Who is
Okay?
it?
Not in this class. Okay? Does that make sense how this sets through?
Yeah. It did.
Give me another one. See where we're at.
Work to get 180.
As you draw this one up,
So this doesn't work. Because it goes over 1. So this doesn't.
oh, you know what? I just realized, I totally forgot that I was going to do it. I figured I was going to teach this differently, like this morning. So Christian, if you're listening, don't do it the way I showed you yesterday. Do it this way.
Okay.
Sine of 43 is to 81. And obviously, they're trying to find, they're forcing me to find what side or angle first here. Work through it. Let's see. We get 62 sine 43 over 81. So my first possible angle for B is 3147.
It's the only possible one.
Well, I'm going to check
You don't know
that
that
then.
yet. You haven't solved it. I haven't done it. Well, we have it.
I haven't either.
Seriously, Ken.
Come on now.
You have to do
Find its supplement.
180 minus 30.
The other one is 148.53.
Equals 148.53.
So we're looking at this one. Hold on. Right off the bat, you'll notice that you've got two acute angles. You know the third one's going to work. So I know that this one will be okay. It's not a problem. 43 and 148 is obviously greater than 180.
So it doesn't work.
So this one won't work.
What are next on?
So that just means you're going to have how many triangles?
1.
One.
One. And I'm assuming you guys could probably do law science to finish that out.
Yeah.
Yes.
Okay.
We can.
It's not that bad, is it?
No.
It's much, much cleaner than the other ways of doing things. The other thing I was going to show you guys today was the idea of finding an area of a triangle that's not right in the head.
Wait, don't you just make it into a right triangle?
You can. You
How
can
do
do
make
magic.
a non-right triangle?
I But you know what? It's so easy to do because what you're doing is you're working with heights.
Yeah.
Okay.
I just said that. Did you not just say height?
No, I didn't.
I said it. Listen to the recording.
Yes,
Am
sir.
I getting drunk?
Walk up there like you're coughing terribly, just in case.
Or give yourself the hiccups.
Regular old boring triangle. You agree? Everybody agrees that also the area of a triangle.
1/2. 1/2.
Wow, I still remember that. What a tough.
Now, what I'm going to do here is draw in my height. You okay with that?
Yeah.
Now, in this case,
That's big.
Don't let her in.
yeah, I might as well. In this case,
As much as we don't.
this here is my little b. You okay with that? Because it's the opposite of big B.
Big B.
So what we'd have to do is figure out 1/2 base times height here.
Right.
I can't because I don't know what the height is. But let's say I knew what this angle was. Isn't this my opposite?
Yeah.
And isn't this my hypotenuse then?
Yeah.
Yes.
Because this becomes a right triangle.
Yes.
So watch this. If I say the sine of A is my height over little c. Sure, I'm going with that? I'm just re-putting those letters in.
Yes.
Yeah, I got you.
To get h by itself is just c times the sine of angle A. That's how that works.
But you do half.
But you don't make height.
Here's what you have to have. The area of a triangle works out to be then 1/2, what do we have? Their base, which is B, times our height, which is C sine of A. What I want you to see, what I want you to notice, I shouldn't keep saying that letter, is that we're working with this side length, and this angle. That looks like what? Side angle side. This, the area for the triangle in this case, if you have side angle side, it works. All it is it's 1/2 your two sides times the sine of the included angle. And it works each time.
That's cool.
It is. It builds off of, it's all it is direct substitution.
Okay.
All right?
Math is fun.
Sometimes. Remember, this works for a side angle side case. It's not to say that I might give you side angle side to start with. I might also give you angle side, which means you have to use the law of sines to find the other side, then do this to make it work. But as soon as you get a side angle side scenario, this formula works. All it is 1/2, your side times your side, oops, I'll show you how to spell, times the sine of the included angle.
That's exciting.
And I know your book writes it out in terms of all three possible cases with A, B's, and C's. Just remember it's side angle side. If you have side angle side, it's 1/2, two sides times the sine of the included angle, and it works. Clean?
Squeaky.
Get it, squeaky.
Good one.
Make my head itchy. Okay. It looked like that.
That means that 12.
Is
Wasn't
that your
that?
children?
24.
No, it's my neighbor's children. I just borrowed them.
Which one? Which one?
More than
Connor?
Ryan?
Not Ryan.
Connor.
More like
Connor's ginger.
No, he's blonde. He's darker blonde than Ryan. Of they give some problems. This is still in section 13.5. Yeah.
This question went by fast.
This did. I
Always doing
and I'm not gonna lie. I had really anticipated it taking a heck of a lot longer than what it did to go through the law sign stuff. And I really truly believe it's the fact that I did not show you the 6 different possibilities that you have to test for. Just do the law signs, find the supplement, and see if it works. If it does, yay! If it doesn't, boo.
Wait, where is Christian? Did he go to sleep with the wrestlers?
I think so.
Good luck, Christian! He's not
He's not
He
wrestling.
didn't make it. You just made it so awkward.
Say you're sorry.
Sorry.
Louder.
Sorry!
Tell me you're gonna buy him coffee.
He
Yes,
was
he
expecting.
does like those.
Why is he going? He was going
This
Those
page.
are his teammates.
because he skipped school, that's why.
I went to state.
You know, I don't even compete with my team. Like, we race each other, and I still like my teammates more than theirs.
Do those, please.
Think about it.
We'll jump through some law cosine tomorrow. I might just give you a lot. I'm going to be in a meeting basically all day tomorrow. I'm probably just going to give you guys law cosine formula and say do it. It's easy.
Is it like this?
Yeah.
Okay.
Law cosines. When we're working with law sines, it's angle side or angle or the side angle. Law cosines is side or side angle side.
I'm gonna get those.
It's very obvious when you see it, because if you have a setup like this, 57, 13, and 5. Can I do law of sines to solve that? No, because I have one angle, no side opposite it, and here I have no other angles. I have to use law of cosines. Now, if I have this, I can do law of sines because I've got this scenario. That's what that is.
Have we gone over law for some year?
No.
Okay, good.
You've done it. You did it last year. It's easy. It's really easy. Yes, ma'am.
What is law of cosine? Would it be like cosine of 57? Or over 13? Okay, what
You
is
make me remember this. Little a b squared plus c squared minus 2bc cosine a? Or is it a squared? A squared? That's right, I think. Is it? Yeah. All right.
Yeah, I don't think it.
Plug and chug. Literally. You should have done this last year. Did you guys do cosines last year?
I don't know. I remember the law of sine.
We did law, I think.
You might have done just one straightforward. It was probably after your chapter 7 test. You probably did law sine, law cosine. Actually, no, you probably did law sine with chapter 7, but did law
I feel
cosine
like that's
after.
something that you told us we didn't really need for
Towards the end.
Oh, no.
Like, taught like a bunch of stuff that like we didn't even know for the option.
Yeah, you probably went through this. And what happens here, if you're looking at law of cosines, what I want you guys to recognize real quick, because I know I won't be around tomorrow. Notice how this
Leave it in here.
and that are on the tails. That's the pattern for these things. Otherwise, it could be b squared is a squared plus c squared minus 2ac cosine of b. Notice how the b's are on the end.
C, BC squared, and
Yeah, and that's how it rotates itself through. Very, very easy to work with.
so 28, you basically just, so there can't be another one.
Right.
Okay.
Yeah. And like I said, that's what I'm telling you. I'm not going to tell you which triangles are going to work right, or which ones are going to be one triangle or two triangles or no triangles. I want you guys to look at the case itself, draw it, and just think about it. Oh, this one already got two angles. It's only going to do one triangle. Okay.
Here's